This video is about materials. Let's review through what we understand about materials using the questions here. Remember to go through the corrections as you watch this video. Now let's read this together. Daniel conducted several tests on 4 materials P, Q, R and S. The results of the tests are given below. So if he's conducting some tests, we must know what properties he is testing or he was testing. Now let's take a look at some of these terms that we reviewed together last week during our remedial lesson. Properties: breaks easily. So if this describe it, what is this property that these words are trying to describe? Yes, it's trying to describe something about strength of materials. Surface is smooth. Now this is not something that we actually learned, but this is about texture. Is a good conductor of heat or not? Now this is something that we have learned in primary 4. So this one is about thermal conductivity. I wish to remind you at this point that if you see me doing annotation, you should also annotate likewise on your worksheet. So when I mark the corrections, I will also see if you are taking notes here in the same manner. Remember, this is a video. You can always pause to make sure you have enough time to copy down what have been written. It's waterproof. So the property being tested here simply is waterproof. Right, so material P is something that is, how do you read this table? This way. Material P is something that yes, it breaks easily. Yes, surface is smooth. No, it's a poor conductor of heat. And no, it is not waterproof. Now Q is something that breaks easily, has a rough surface. How do you know it is rough? Because it says no. Is it smooth? No, it is not smooth. Here, it does not break easily, so it is strong. Is it a good conductor? No, it is not a good conductor of heat. Is it waterproof? Yes, it is waterproof. R is something that, yes, it breaks easily, so it is not a strong material. R is something that is not smooth. R is something that is a poor conductor of heat. R is something that is, yes, it is waterproof. Finally, S is something that does not break easily, so it is strong. It is something that has a rough surface. It is a good conductor of heat, and it is waterproof. Now, typically after you see something like this, the question will ask you to apply the knowledge and use the information here and apply into a situation such as this, which is, which of the above materials is most suitable for making the handles of frying pans? Of course, you may highlight as well, so let's take note. This is a real life use, handles of frying pans. Now let's do a quick sketch of how it looks like. So this could be a frying pan, alright, and this would be a long handle. There could be a portion here, alright. So let's say, so this will be the handle. I will also wish to see this picture when I actually see your worksheet. And this is a frying pan, and the pan is over a flame. And this would be the heat source. Now, would this part of the frying pan be a good conductor of heat? Of course it has to. But if this part is a good conductor of heat, wouldn't the heat be transferred all the way up here to the handle? And if the person were to hold on to the handle, wouldn't the person be burnt or scalded? So therefore, this handle has to be something that is a poor conductor of heat. So a person can hold on to this handle safely without any fear of getting burnt due to the heat from the heat source that got transferred all the way through this material. So first and foremost, I must look at the material that is a poor conductor of heat. So look at this row. Is it a good conductor of heat? I look at all the things and say, no, no, no. I'll consider these 3. Next, would I want it to break easily? Of course, I wouldn't want the handle to break easily. If not, then this whole pan and the contents inside, which could be soup or stew or meat, could just fall onto the ground and may hit me. So I will want the handle to be made of a strong material that does not break easily. So let me take a look here. Break easily, yes, no, I don't want this. No, okay, I would love this. Oh, have I already got my answer? Let me check one more time. Now, texture, is it smooth? No, it is not smooth. That is good. If it's too smooth, when I'm holding to it, it may just slip off out of my hand. So if it's rough, I can hold on to the handle better. Alright, and with better grip, it wouldn't slip off so easily. Lastly, is it waterproof? Yes. Well, this is not too important to me. It can be waterproof, it may not be waterproof, it is fine. But the most important thing is this. It must not be a good conductor of heat, and it must be strong, so it cannot break easily. So I will choose material Q, which is number 2. Right, let's go on to the next question. Now, Jovan wants to make a diving springboard as shown below at the swimming pool. So this is a springboard. Now, the table shows the characteristics of 4 materials A, B, C, and D. A, B, C, and D. And these are the 3 different characteristics: waterproof, strong, and flexible. Now, how does this work? We must first understand the story here and understand how it does this work. So if the person were to jump off a springboard, now I don't see any springs here, but what happens is this will behave like a plastic ruler. If he were to jump onto this end, then this springboard will naturally bend downwards, but it will also spring backwards, and when it do so, it will make this person fly forward or upwards. Therefore, this springboard has to be cannot be too stiff. It has to be a little bit elastic, but yet it cannot break. Imagine if you were to stand here and jump on this and this thing breaks, that will be an accident in the making. Alright, and this is a swimming pool. This would be good if it is waterproof. But let's check through now. The most important thing is not waterproof now, but the most important thing is that it must be strong, it must be flexible. So when I look at the materials, the only material that is both strong and flexible is D. Strong and flexible. Right, and it has an added bonus, it is also waterproof. Now, which of these materials is therefore most suitable? Answer is very clear, it is D. Answer is 4. Now let's go on to the next question. Now, for the following questions, do take note, it's important to read the instructions as well. Write your answers in the spaces provided. The number of marks available is shown in brackets at the end of the question or part question. Now, Mendel conducted an experiment using the setup below. Now, I already pre-prepared some notes here. Now, let's take note. Now, this is a container here made of a certain material S. And this container contains a liquid at quite a low temperature, at 20 degrees Celsius. This is like a very cold air-conditioned room temperature. And imagine a thermometer inside. Can you draw this thermometer in such that the bulb, which is this portion, is right in the middle of the liquid? And then the outer basin is made of a different material. Alright? And inside here contains some water at 95 degrees Celsius. And this is really high, it's almost boiling. Remember the boiling point of water? Boiling point of water will be at 100 degrees Celsius. Now take note of the temperature difference between these two liquids. One, this is very high temperature, and this very low. So what do you remember about heat transfer? Now go to the top here. So what can you remember about heat transfer? Now I hope that you also have a doodle book with you. If you do not have it, pause it now and go and get it and open up to the page on heat energy. Alright, welcome back. So heat transfer. This is a transfer of heat energy. From where to where? From a place of higher temperature, short form, to a place of lower temperature. See, lower temperature, higher temperature. But does it keep on going? It does until, when will it stop this transfer? The transfer will stop until both reaches the same temperature. Okay, so this girl here, Amanda, she measured the temperature of liquid Z in the container over a period of time, and she repeated the experiment using a container made of material T. So the first time she did, she used material S. She recorded the temperature over time, alright, and she noticed that it was temperature of the liquid inside, the cold liquid, was increasing over time. Right, this line here represents time. This line here represents the temperature. Now she repeated the experiment using a container made of material T and plotted her results in the graph shown below. Alright, so material T will be this one. Now, how do we understand this graph, or how do we read this? Now, first take note, the liquid in the container started off at the same temperature at first. Remember what was its temperature? See here? It was at 20 degrees Celsius. Please write this down. Now I'm going to put some time here. Why did I write this here? So we can better understand the situation. Right? She did it over a period of time, let's say over 3 hours. So what happened in that 3 hours? Let's say after 1 hour, for material S, if it's 20, this could be, let's say, for example, 40, this could be, for example, 60, this could be 80. Alright, you do not have to draw the dotted lines. You just need to understand how to read this line graph. So after 1 hour, for material S, the liquid inside there will be around between 40 to 60 degrees Celsius. Probably around 55 degrees Celsius. I'm going to just write a number. Remember, this is not accurate, this is just my estimate. But for material T, after 1 hour, the temperature inside is only somewhere at 39 degrees Celsius. It's lower. It is like the heat transferred to the liquid Z in container S much faster. That's why the liquid inside container S actually heat up much faster. After 1 hour, it was higher. Let's see, after 2 hours, the liquid in container T actually only increased a little bit more to around maybe 45 degrees Celsius, but the liquid in container Z increased all the way up to about 60 to about 70 degrees Celsius. From this, you can already infer which material, S or T, is a better conductor of heat. What do you think? Which one is a better conductor of heat? If you say that S is a better conductor of heat, you are correct. Write this down. Better conductor of heat. And T, of course, will be a poorer conductor of heat. So let us try to explain why the temperature of the liquid Z increases as time increases. You notice no matter how fast or slow it's happening, both line is inching upwards. You see, it's going up from left to right. It's going up from left to right. This tells you it's increasing. Temperature of Z is increasing over time. So explain, how does this happen? This requires us to go all the way back to the concept that's being tested in this question, which is about heat transfer. The transfer of heat energy from a place of higher temperature to a place of lower temperature until both reaches the same temperature. They both reach the same temperature. So let's check this now. The heat from the hot water in the basin flowed to liquid Z. Remember, the hotter place was the one inside here. This place was the hotter place, the one with water at 95 degrees Celsius. And the heat was transferring through this container, alright, into the liquid Z that's inside. And this made the liquid Z inside hotter and hotter. Therefore, the temperature of the liquid Z is rising higher and higher. So there are two ways you can answer this. You can either say the heat from the hot water in the basin flowed to liquid Z, or you can say liquid Z gained heat from the hot water in the basin. Next question. Amanda wants to keep her ice water cool for a school trip. Which material should she choose? Give a reason for your answer. Now, she wants to keep it cool. That means that she wants to, imagine now this is her water bottle, and she pours cold water inside when she's at home. Then she wants to go to a school trip. But by the time she gets to the school bus, to get to school, the water inside will have gained heat from the surroundings. So how can we slow down the heat transfer so the water stays cooler for a long time? Let's take a look at these two graphs. Which one, S or T, is actually slowing down the gain of heat by liquid Z? If you say T, you are correct. It is slowing down. So of course you must choose material T. And give a reason. It's saying, going back to the same concept being tested, it's about heat transfer. So right now we need to explain that T is a poorer conductor of heat that will slow down the rate of heat gain by her ice water. So T is a poorer conductor of heat that will slow down the rate of heat gain by her ice water. From where? From the surroundings. So take note that for heat flow question, you need to take note of some words. You need to make sure you have made some comparison. So by saying it is a poorer conductor of heat, you have made a comparison. And when you talk about heat flow and the heat flow, heat gain, you got to know from where to where. By her ice water from the surroundings. Now, last question. This question is actually about absorbency of material, or whether material is waterproof or not. Amy set up an experiment to find out which material, PQRS, was most suitable for making a raincoat. She poured water onto 4 sheets made of the 4 materials that were secured at the rim of 4 similar beakers, A, B, C, and D. And the amount of water collected in each beaker and on each material is shown below. Okay, so imagine her pouring water in to each of these. Same amount of water, same type of water. Now for beaker A, right, what I'm going to go through is understand the picture. Once you understand the diagrams given in the story in this question, in Amy's question, you will then be able to understand how to do this. When Amy poured water into over material P here, she realized the water got stuck on top. It didn't go through at all. That's why this is empty. So what can you say about material P? Would you say it is waterproof or it absorbs water? Very good. It is waterproof. Let's write this down. Waterproof. Next, for beaker B. When she pours water in, no water was left on top. All the water ran right through and ended up in the beaker itself. So you would say that this material is not waterproof. Let's write short for that. Not waterproof. WP. Waterproof. Next one, material R. Pours water in. Strangely, only some water got here. So where did the rest of the water go to? It could have been absorbed inside this. But the fact that water could go through, and the fact that this can absorb water, means that material R is also not waterproof. Finally, material S, when you pour water in, alright, some water got through, alright, some water stayed on top, so it absorbed some water, it did not allow some water to go through, and most of it went through. So this definitely is not like this, where the water got trapped on top. This material definitely is not waterproof. Now state the variables that must be kept constant. Constant means same. A reminder again, whatever annotation you see here, you have to have them inside your worksheet as corrections. State the variables that must be kept the same or kept constant in Amy's experiment. Now what is her aim here? The aim will come from this, the clue comes from this tribute to find out. What was he trying to find out? Try and find out which material is suitable for making a raincoat. Please write down aim. Now what do you think is a function of a raincoat? Well, raincoat is to keep us dry. To keep us dry, therefore, it has to be waterproof. And since she's testing 4 different materials, this variable, which is a type of material, must not be the same. She must change the material every time she tests it, so she gets to make some comparison. But all the rest must be the same. For example, you can say that the amount of water must be kept the same. Otherwise, it's not very fair, right? You pour more into one container and less into the other. Right, since they say variables, we try to give another one, at least two. Because 2 marks here, and this is plural. So these are clues for you to tell you how much answer must you give to get the full marks. Okay, so let's say, how about the size of the material? If I use a very small size material for Q and a very large one for this, or a very thin one for this material and a thick one for this, you will say it's not fair. Right? In order to be fair, we must keep those variables constant, such as the thickness of each material. There you go. I have 2 variables here that are definitely must be kept constant. Next, Amy concluded that material R is most suitable for making a camping tent. Her friend Lily disagrees. Explain why Lily is correct. What's a camping tent? Well, you are out in the wild, alright, you may need some shelter from the rain or from the sun. A tent looks something like this, alright, you need to make sure you anchor it with some pegs, wooden pegs, and you make sure you hold it up with some frame, and then you tie it to the ground. So when it rains, and if you are hiding inside, alright, this material should not allow water to go through. This material should be waterproof. Let's see, R. Is R waterproof? No. You see, some water could go in, and this material could absorb some water as well. That means that if this R is used to make the tent will become very wet, very heavy, very soggy. Imagine you're inside, and this wet, soggy tent will just fall on you. Not to mention that rainwater has already gotten through it before this whole tent collapses. So therefore, why Lily is correct? Simply tell us that you know that R is not waterproof. And a tent, which is a camping tent, has to be waterproof. Why? To keep us dry. So which material is most suitable? Think of the word most suitable for making a raincoat. Remember, raincoat, we talked about it earlier on. Function is to keep us dry and must be waterproof. So there's only one waterproof material here, and that's material P. So must be P, no other answer. Simply because P is waterproof. And a raincoat has to be waterproof to keep us dry. By now you notice that actually, sorry, didn't see this part. P is waterproof and a raincoat has to be waterproof to keep us dry. So this is a pattern to the answer. This first part that I'm going to highlight. R is not waterproof. P is waterproof. You will answer it with a property of the material. A property of the material. And the second part, which I will bracket, okay, you will tell us you understand the function of the material. Sorry, the function of this object called the raincoat, the function of this object called camping tent. By doing so, you get the full marks for this. Right? I hope you have found this lesson to be useful. Please tell me more tomorrow. Thank you.